Good morning friends, welcome to my new YouTube channel. Today we are going to learn about the proof of ASTC rule. So friends, don't think that I'm a math genius. I am a student and I do believe that I understand the problems that are being faced by every student like me. Okay? So before starting, I would like to suggest that please have patience because maths is not a minus trick. So have patience and watch the video till last. Okay? Let's start. What ASTC rule says is that every trigonometric function have positive values in the first quadrant, means sine, cos, tan, cot, cosec, sec. Every trigonometric functions have positive values. Remember, have positive values in the first quadrant, and only sine and cosec have positive values in the second quadrant. Only tan and cot have positive values in the third quadrant, and cos and sec have positive values in the fourth quadrant. Okay. And the term ASTC have come from all A sin S tan T cos C, A S T C. Okay, before the proof you have to know a very important theorem, that is reference angle theorem. As you may be knowing that every angle is related to other angle in some or another way. Remember, every angle is related to another angle in one or another way. Okay, means every angle can be represented by some another angle. Here, this big angle 90 plus theta can be represented by this phi. Means, let's assume that sine 90 plus theta, this angle, is equal to sine phi. Yes, it is really. Sine 90 plus theta is always equal to sine phi. The sine of this angle is always equal to sine of that angle. It may be another case. This means sine of this angle is equal to sine of this angle, or sine of this angle is equal to this angle. Okay, means, so I will give you a example that, okay, sine of 150 is equal to sine of 30. Okay, sine 150 equal to sine of 30 means this is 150, this is 150, this is 30, means this it is also half and this is also half, means these two angles are supplementary. That any trigonometric function having this value will have same value with any trigonometric function with this value. Okay, now we call in a math language this angle as is reference angle. So what will be reference angle of this angle? That will be this, means 270 degree minus x if 180 is plus theta is equal to x. Similarly, the reference angle for this angle is this. I will tell you again that the reference angle for this angle is this, means 180 minus, if this is equal to x, then 180 minus x equal to alpha. So reference angle of this big angle is this. In the second case, reference angle of this angle is this, and reference angle of this big angle is this. And what reference angle theorem says that every trigonometric function or every trigonometric value can be shown by its reference angle. Okay, if the trigonometric value of any bigger angle can be found easily with the help of its reference angle. Remember that the trigonometric value of any angle, means any bigger angle, can be found by its reference angle. Okay, so let's check its validity. The reference angle for sine 1 is 179. Okay, and see that these two values are exactly equal. Wow, miracle, isn't it? Similarly, sine 2 and sine 178 are reference angle, these two values are equal. Sine 30 and 150 are reference angle, and these two angles are equal. The reference angle of 111 is 69, and these two values are equal. Okay, and let's go to the proof. Okay, the proof, which is long awaited. Okay, let's sine of 90 plus theta. Okay, let's leave it. We take a vector quantity here. we have it just theta. Okay, if this angle is rotated 90 degree, means this whole angle will be 90 plus theta. Since this two triangle will become similar, so this will also be theta. Okay, now what we are going to say is that this the trigonometric ratios of this big angle can be shown by its reference angle, which is alpha. Okay, is it all clear? Okay, now let's take this as x and this as y and this arm as r. Okay, this is r. When rotated, this will also become r. This is y and this is x. Okay, now this will also become a triangle. Here let's sin 90 plus theta. Okay, sin 90 plus theta, let's draw a line here. Sin 90 plus theta is equal to sine of phi. Is it all clear? Sin 90 plus theta is sine of phi, which I have stated in the reference angle theorem. This will be equal. Here, what is the value of sine phi? Sine phi is equal to y by this r. Okay, and what is the value of y by r in this triangle? Since these two triangles are similar and also congruent, what is y by r in this triangle? OCB. Okay, y by r is equal to, in this triangle it is y by r is equal to cos of theta, which is positive. Okay, it will be positive here. Similarly, what will be the cos 90 plus theta is also can be shown by cos of alpha. Okay, what will be the cos of alpha? Cos of alpha will be this x, which is a negative quantity, means minus x by r. This is r. Okay, by r. What is x by r in this triangle? X by r is minus of sin theta, means cos 90 plus theta is always negative. Okay, similarly tan 90 plus theta is equal to tan of alpha. Okay, what will be the tan of alpha? Tan of alpha will be x, okay, sorry, y by r, y by minus of x. Okay, what is y by x in this triangle? That will be minus of cot theta. This means that the tan is also negative. So it proves that in the second quadrant only sine have positive value, and this can be proved by this Cartesian plane. Have you understand? Hope you will. In the second, let's say in the, I'll do it by hand. So I have it. Okay, in the third quadrant, this is the big angle, means 180 plus some theta. Okay, so we have rotated it. This is x, this is y, this is theta. Okay, this is the r to there. We have rotated this vector by a degree of 180 degree, then it comes here. So here the reference angle is this alpha. Okay, and then sine 180 plus theta is equal to sine of alpha by reference angle theorem. Okay, sine 180 plus theta is equal to sine alpha. So let's make this a triangle. This will be minus of x, and this will be minus of y. Okay, sine 180 plus theta equals sine alpha. Here sine alpha is minus x. This is r. Okay, minus x by r. What is x by r in this triangle? That is minus of cos theta. So sin 180 plus theta means any value of sin in the third quadrant is always negative. Okay. Similarly, cos 180 plus theta is equal to cos of alpha. Cos of alpha means minus y by r. What is y by r in this triangle? Y by r is minus of sine of alpha. This also states that any angle with cos in the third quadrant is also negative. Now let's come to tan 180 plus theta is also equal to tan of alpha by reference angle theorem. Tan of alpha in this angle triangle will be minus x by minus y, means x by y. What is x by y in this triangle? That is cot theta. Okay, and it is a positive value in the third quadrant, and similarly in the fourth quadrant in the fourth quadrant, sine will be negative, sine theta will always be negative, cos theta will always be positive, and tan will also be negative. Thank you for watching the video and hope you will like it and subscribe my channel. Thank you.